And the question here is, given limit is limit x tends to 0, x cube cot x divided by 1 minus cos x. So obviously, if you put x is equal to 0 here, it is going to you're going to get an indeterminate form. So therefore, what we do is we multiply the numerator and denominator, because we see a 1 minus cos x in the denominator. You multiply the numerator and denominator by 1 plus cos x. Okay. In the next step, in the denominator, you are going to get 1 minus cos square x. Right? And in the numerator, you are going to write cot x is cos x by sin x. That means we have changed everything in terms of sin and cos. Okay. In the next step, in the denominator, you will get sin square x. Okay. In the numerator, and if you take cosine x in the to the denominator, it is actually going to become sin cubed x, right? Because we have a sin x here. This sin x you take to the denominator, this will become sin cube x, right? So in the numerator, you will be left with x cube cos x into 1 plus cos x. Okay. And in the next step, if you see, you have a sin cube and an x cube there, right? That means this limit can now be written as limit x tends to 0 cos x into 1 plus cos x. And the x cube that you have in the numerator, you can take this to the denominator of the denominator. That is sin cube x by x cube. Okay. That means now I can distribute the limits over the numerator and the denominator. Limit x tends to 0 cos x into 1 plus cos x divided by limit x tends to 0 sin x by x cube. Sin cube x by x can be written as sin x by x whole cube. Now you know that limit x tends to 0 cos x is 1. So therefore, in the numerator, you can further distribute the limit over this product. So you can write this as limit x tends to 0 cos x into limit x tends to 0 1 plus cos x divided by, and in the denominator, you can take the limit inside the power whole cube, right? Now limit x tends to 0 cos x, this part here is 1, and the rest you can distribute this limit over limit x tends to 0 1 plus limit x tends to 0 cos x, and the denominator you have 1 cube, because limit x tends to 0 sin x by x is the standard limit. So now you see you have 1 into 1 plus limit x tends to 0 cos x is 1 divided by 1. So what you're getting here is 2, and that should be your answer. Okay, any question?
No, sir.
We'll move to the next question, next set of questions in this exercise. The given limit here is limit x tends to pi by 2, 1 plus cos 2x divided by pi minus 2x whole square. Okay. Now, if you see, if you put x is equal to pi by 2, you're going to get an indeterminate form, isn't it? Because in the denominator, you get pi minus pi. So you're getting denominator equal to 0, which is an indeterminate form. So therefore, normally when you get x tend to something which is a non-zero value, here x tends to pi by 2. Normally what we do here is that we say let x minus pi by 2 is equal to h. This is the normal substitution that we do. Whenever you see x tending to some non-zero value, you take x minus that non-zero value is equal to h. So that means you get x is equal to pi by 2 plus h. This substitution will actually help you evaluate the limit very easily. Okay. So therefore, when we get
Okay,
x
sir.
is equal to pi by 2 plus h, therefore as x tends to pi by 2, h will tend to 0. So therefore, what have we done? We now change everything in terms of h. So x tends to pi by 2 becomes h tends to 0. 1 plus cos. Twice x is pi by 2 plus h divided by pi minus twice pi by 2 plus h. Right? Now we simplify this a little. Limit h tends to 0. 1 plus cos, if you multiply twice pi by 2 plus h, you will get pi plus 2h divided by pi minus, and if you multiply 2 with pi by 2 plus h, you are going to get pi plus 2h, right? So limit h tends to 0, 1, and you have cos pi by pi plus 2h. From your associated angle, you can write this as 1 into pi by 2 plus 2h, right? 2 into pi by 2 plus 2h, isn't it? Divided by, and in the denominator, if you open the brackets, pi minus 2h, right?
So,
Yes.
sir, there is a square in the denominator, pi plus 2h.
Oh, there's a
So,
square. Okay. We put the
yes.
square there. This is a square, and this is also a square. So this is square. Now this becomes limit h tends to 0. Cos 2 into pi by 2. So if you see 2 into pi by 2 plus something means it is in the third quadrant, right? In which cos is negative. So I have 1 minus. And since there is an even multiple here, so I'll write cos. Cos remains cos. It's 2h divided by minus 2h square, right? This pi and this pi will cancel, so you'll only be left with minus 2h square. So limit h tends to 0. 1 minus cos 2h from your multiple angle formula, you can write this as 2 sine square h divided by 4h square, right? So now what can you do? You can take 2 by 4 out of this limit to only write this as limit h tends to 0 sine square h by h square, right? Which can be written as half limit h tends to 0 sine h by h square, which can now be written as half. And now you can take the limit inside the bracket, inside the power, write this as sine h by h square, which is equal to half into 1 square, which is equal to half. Okay, and that is the required value of the limit. Okay, next question. Question number 2. Given limit here is limit theta tends to pi by 2 sec theta minus tan theta. Okay, as I told you that you see theta tends to pi by 2, what you can do is you can write this as theta minus pi by 2 is equal to h. That means theta will become pi by 2 plus h. Therefore, as theta is very close to pi by 2, then h must be very close to 0. Therefore, limit will now become h tends to 0. Sec theta is pi by 2 plus h minus tan pi by 2 plus h. Okay, which is equal to limit h tends to 0. Now sec pi by 2 plus h. This is an even multiple, isn't it? A odd multiple, 1 into pi by 2, right? So, and the second quadrant. In the second quadrant, sec is negative. So we give a negative sign, and sec will become cosec because it's an odd multiple. So minus cosec h. And what about 1 into tan pi by 2 plus h? Second quadrant, tan negative, and tan will change to cot. So cot h, right? So this becomes limit h tends to 0. You can change everything to sine and cos. So you have minus 1 by sine h plus cos h by sine h. Okay. So you're going to get limit h tends to 0. Cos h minus 1 divided by sine h. Okay. In the next step, you can take the minus out to write 1 minus cos h divided by sine h. And this negative sign can also be taken out of the limit. So I can write this as minus limit h tends to 0. Now 1 minus cos h. From multiple angle formula, what is 1 minus sine h? 2 sine square h by 2, right? Divided by, and sine h from multiple angle formula is 2 sine h by 2 cos h by 2, right? Which is equal to minus limit h tends to 0. This 2 and this 2 will cancel. One sign will cancel here. So you're only going to be left with tan h by 2, right? Now tan h by 2, what is the standard limit for tan? Limit x tends to 0, tan x by x is equal to 1. So what is missing in the denominator? H by 2 is missing in the denominator. So I multiply this by h by 2. And because I am multiplying this by h by 2, I need dividing by h by 2, I need to multiply this also by h by 2, right? So now I can separate the limits. So I get minus limit h tends to 0, tan h by 2 divided by h by 2 into limit h tends to 0, h by 2, right? Now limit h tends to 0 tan h by 2 by h by 2 is a standard limit. So I get this as 1. And here now you can put h is equal to 0. So you get minus 1 into 0, which is equal to 0. Okay. Now this is one way of evaluating this limit. And this is a little longer. What you can also do here is, you see that the given limit here is, if you don't want to put theta minus pi by 2 is equal to 5, even then this can be evaluated very easily. You have sec theta minus tan theta, isn't it? Now you know that
Yes,
sec
sir.
square minus tan square is equal to 1, isn't it? That is something that you can use here, because in most 90% of the problems, this substitution will help. Okay, and it has helped in this problem also. But however, what I want to tell you is that when you see something standard, that is sec square minus tan square is equal to 1. So we try to bring this to that form. That is, I write this as theta tends to pi by 2. I multiply the numerator and denominator by sec theta plus tan theta, right? can write this way without changing the variable. I'm working with theta only here because I see sec theta minus tan theta, and I know at the back of my mind that sec square theta minus tan square theta is 1. So in the numerator, if you see, I'm getting sec square theta minus tan square divided by sec theta plus tan theta. Okay. Now we are getting an infinity form here, I think, because if I put sec tan pi by 2 is infinity. So 1 by sec pi by 2 plus tan pi by 2. In that case, again, we will have to change to sine and cos. Limit theta tends to pi by 2. I get 1 by, and now what I do is I change sec theta to 1 by cos and tan theta to sine by cos. So I get 1 plus sine theta by cos theta. Okay. Then theta tends to pi by 2 cos theta by 1 plus sine theta. Again, I see I get a, if I put theta is equal to pi by 2, I'm going to get, will I get the required limit? Cos pi by 2 by 1 plus sine pi by 2. I think I'm going to get a determinate form now. So cos pi by 2 divided by 1 plus sine pi by 2. Right? How much is cos 90? 0. That's 0. And that should be your answer. Clear? You can do it this way also without changing the limit. Any question?
No, sir.
Okay, next question. Number 3. Given limit here is limit x tends to 1, 1 minus x tan pi x by 2. Okay. Now see here, limit x tends to 1 is here. So what I do is I change the uh, variable first. That is, I take let x minus 1 is equal to h. That means I get x is equal to 1 plus h. Therefore, as x tends to 1, h tends to 0. So therefore, what is L? L is limit h tends to 0. 1 minus x is 1 plus h, right? And you get tan pi by 2 times 1 plus h, right? Now we simplify this a little. Limit h tends to 0. You get a minus h, and you get tan. If you multiply pi by 2 throughout, you get pi by 2 plus pi h by 2, right? And now you can take this negative sign out of the limit, minus limit h tends to 0, h. Now tan pi by 2 plus pi h by 2 from negative associated angle, this is an odd multiple, right? 1 into pi by 2, and it is in the second quadrant. So therefore, you're going to get a minus sign, minus, and tan will change to cot pi h by 2, right? So now again, this negative sign will go out. This will become a plus sign. So I can simply write limit h tends to 0, h cot pi h by 2, right? Now you know you can change cot to tan, right? This as h by tan pi h by 2, right? Now you know limit x tends to 0, tan x by x is a standard limit. So we are trying to bring it to that form only. So what happens? This h will bring this to the denominator. So I can write this as 1 by tan pi h by 2 by h, right? I can write this way, which is equal to limit h tends to 0. What is missing here? There is only an h. So pi by 2 is missing. So I can write this as 1 by tan pi h by 2 by, if I multiply by pi by 2, I get a pi h by 2. But because if this I'm multiplying the denominator by an extra pi by 2, and you need to multiply this by pi by 2. So that means this is limit h tends to 0, 1 by tan pi h by 2 by pi h by 2, right, into 1 by pi by 2, right, which is equal to, now 1 by pi by 2 is 2 by pi, which you can take out of the limit. 2 by pi is a constant, and you can distribute this over this. So limit h tends to 0, 1 divided by limit h tends to 0, tan pi h by 2 by pi h by 2, right? So you get 2 by pi into 1 by 1. So simply 2 by pi. And that's your answer. Any question in this problem? Okay, we'll move to the next problem. Number 4. Question is, limit x tends to infinity. Sine x by x. Okay, why is this question given? You know sine x by x is 1. Then why can't I write this as 1? Can you tell me why I can't write this as 1 directly? Can you tell me why I can't write this as 1 directly? Anyone? Because limit x tends to infinity. In the formula we had limit x tends to 0. Here I have limit x tends to infinity. That is why I cannot write this as 0. So what I do is I try to change the variable and try to get something by y tends to 0. So what I do is I say let y is equal to 1 by x. Okay, so that means x must be equal to 1 by y. Therefore, as x tends to infinity, y will tend to 0. So therefore, this limit now, if I change in terms of y, it becomes limit y tends to 0 sine x is 1 by y. So I write this as 1 by y. And in the denominator, I write also this as 1 by y. So what I get is limit y tends to 0, y sine 1 by y. Okay. Now, what will be the value of this limit? Y into sine 1 by y. If you put y is equal to 0, is sine 1 by y, is it a finite quantity? 1 by y, 1 by 0 is a huge quantity, right? Sine of 1 by y, sine of infinity, a very huge quantity. That means, but you know that the value of sine, howsoever huge the angle is, the value of sine will also always lie between -1 and 1. That means this is y, this is 0. If I now put y is equal to 0, 0 into some finite quantity. Why finite quantity? Because sine 1 by y will always lie between -1 and 1, right? So this is equal to 0, value of this limit. If this would not have been a finite quantity, I'm asking you, if this would not have been a finite quantity, if this would have been not been a finite quantity, then can we write 0? Is 0 into infinity equal to 0? Tell me, is 0 into infinity is equal to 0? Can you tell me is 0 into infinity is equal to 0 or not? Okay, so 0 into
Yes.
infinity, yes, tell me.
Sir, it will be 0.
And who says so? That 0 into infinity will be 0?
Sir, I am guessing, sir.
Kushi is saying 0 into infinity is 0.
Yes, sir.
0 into infinity is not 0. In fact, 0 into infinity is not
Why?
equal to 0. 0 into infinity is an indeterminate form. 0 into infinity is an indeterminate form. Amongst other forms, 1 to the power of infinity, 0 to the power of infinity, infinity by infinity, 0 by 0, all these are indeterminate forms. Okay, so when you're multiplying 0 by an infinite quantity, we don't get 0. It's an indeterminate quantity. We don't know its value. Okay, so we'll be dealing with these with these indeterminate forms later. But for the time being, just note that 0 into infinity is not 0, and there are certain indeterminate forms. These are some of the indeterminate forms. The most standard indeterminate forms are these two. Okay, which we'll be dealing with at the end. Okay, at the end of our syllabus. Okay, let's move to the
Okay.
next question. Okay, number 5. The given limit here is limit x tends to infinity, square root of x plus sine x divided by x minus cos x. Okay. Now, here if you see, x is again tending to infinity in this, right? So what we do here is, you can first change uh, x tends to infinity to y tends to 0. So I say let y is equal to 1 by x. That means x is equal to 1 by y. So therefore, as x tends to infinity, y tends to 0. So therefore, L will become limit y tends to 0, square root of 1 by y plus sine 1 by y divided by 1 by y minus cos 1 by y. Okay, which is equal to limit y tends to 0. Now if I take the LCM in the numerator and the denominator, I am going to get 1 plus sine y sine 1 by y, right? Y sine 1 by y. And in the denominator, I am going to get 1 minus y cos 1 by y, right? Okay. Now what happens? Because there is a square root, that means this function is raised to the power of half. This limit now can enter the radical. Is this step clear? Is this step clear?
Sir, I could not hear. Can you please repeat?
You know that uh, limit x tends to a fx to the power of n is equal to limit x tends to a, this is a, fx whole to the power of n. Here n is half, isn't it? Because it is a square root. So therefore limit can enter the radical.
Yes, sir.
That is why the limit has entered the radical.
Yes, sir.
Okay. So now what I do is I distribute this limit over the numerator and the denominator inside the radical. So inside the radical, it is going to become limit y tends to 0, 1 plus limit y tends to 0, y sine 1 by y divided by limit y tends to 0, 1 minus limit y tends to 0, phi cos y cos 1 by y, right? Which is equal to square root of limit x tends to 0, y tends to 0, 1 is simply 1. And again, this I already showed you in the last question. This is, you can put y is equal to 0 because this will be 0 into some finite quantity which will be equal to 0, right? 1
Yes.
minus, and this, if you put y is equal to 0, again, this is also y 0 into some finite quantity, isn't it? Cos 1 by y is also finite because cos also lies between -1 and 1, right?
Yes, sir.
So that is why this becomes root over of 1 plus 0 by 1 minus 0, which is equal to 1. And that's your answer. Okay. Okay. Next problem. Number 6. Given limit is limit x tends to theta tends to pi by 6 cot square theta minus 3 divided by cosec square theta, cosec theta, in fact, cosec theta minus 2. Okay. Now you see that you have a cot and you have a cosec. Okay. If you write theta minus pi by 6 is equal to h, this is going to complicate matters a little. But because you are seeing that there is a direct relation between cosec and cot, what is the relation between cosec and cot? Cosec square theta is equal to 1 plus cot square theta, isn't it? So there's no need to change the variable of this limit, because if you change the variable, this is going to, you can solve it definitely, but it's going to take a little bit of effort in solving. In fact, this problem, because you know that cosec and cot are related, you can reduce your effort. Why? How? You can change this cosec square to cot square to cosec square theta minus 1 minus 3. And you can write the denominator as it is, cosec theta minus 2. So this becomes limit theta tends to pi by 6. You have cosec square theta minus 4 divided by cosec theta minus 2. Right? Now this cosec square theta minus 4 is a difference of two squares, right? Theta tends to pi by 6 cosec theta square minus 2 square divided by cosec theta minus 2. Right? So now you split the, factorize the numerator into a plus b into a minus b. So you get cosec theta plus 2 into cosec theta minus 2 divided by cosec theta minus 2. Okay. So here this will cancel. So you ultimately get only limit theta tends to pi by 6 cosec theta plus 2. Now if I put theta is equal to pi by 6 now, is it a determinate form? Yes, it is a determinate form. So this becomes cosec pi by 6 plus 2. Cosec pi by 6 is 1 by sine pi by 6 plus 2. And one sine pi by 6 is sine 30, which is half, right? Which is 2 plus 2, which is equal to 4. And that's your answer. Okay. So I'll stop here.
Yes.